This is section 3.2. We're going to be talking about the slope of a line. Now, just in general, what a slope is it tells us how steep our line is. It will be the way numerically we talk about a line that goes like this, how it's different from this to this, or from here to here. We're talking about numerically that difference by how steep our line is, okay? The formulas for slope, first of all, we use the letter M for slope. I've been told it comes from the French word for slope, but I'm not positive about that, okay? But it doesn't matter why we do it, we just do, okay? Now, one definition of slope is the change in y over the change in x. Now, this definition is mainly used for understanding. We don't actually plug into it much. It just helps you understand, basically, it's a ratio. We're taking how much the y changes over how much the x changes. Then we have rise over run, and this is a formula that a lot of people remember even if they don't remember how to use it. We use rise over run when we're graphing. Now, all of these are saying the same thing. It's just a different way of dealing with it depending on what we're going to be using a slope for. Then we also have y2 minus y1 over x2 minus x1. You use this when you're given 2 points. And the points we would call x1, y1. Notice your ones are together. And then x2, y2. So the change in your y, you're going to take this one minus this one over your change in x, which is this one minus this one. Okay? All right, so there are a couple of things that you can tell just by knowing the slope. And I know you guys are going to be using graphing calculators eventually, but I want to make sure that you know enough about slope and the way they work so that when you enter something in a graphing calculator and then you get the picture and you will recognize maybe that it's totally wrong if you made a mistake on entering it. So this is sort of like giving you enough information to recognize quickly whether something is wrong. In a particular form where we are not there yet, you will be able to just look at an equation and know what the slope is. Okay, so I need you to trust me a little bit on that right now. There are certain things we can tell from our slope. Like I said, you will be able to look at our equation when it's in certain forms and know your slope. If your slope is a positive number, it does not matter what that number is. If it is a positive number, then your line is going to go up when you look at it from left to right. Now, if your number is small positive, it's going to be close to flat. If your number is a big positive number, it's going to be very steep. Okay? But numerically, if it's positive, it's going up. Maybe just a tiny bit, but it's going up. Okay? Likewise, if your slope is a negative number, your graph is going to go down from left to right. Again, if it's a small negative number, it's going to be closer to flat. If it's big, it's going to be very steep. Okay, so our slope can be positive, it can be negative, but it also could be zero. A zero slope has a horizontal line. Okay? It's not going up, it's not going down, because 0 is not a positive number and it's not a negative number. Okay? You want to start to kind of keep things in mind about a zero slope and a horizontal line. This stuff is going to keep popping up. We're going to keep seeing it in different formats as we go through this chapter. If your slope is undefined, you will have a vertical line. Now, how can it be undefined? If your x values are the same, like if this is a 3 and that's a 3, then I have a 0 in the bottom, and we can't divide by 0. So undefined is going to happen when your denominator is 0. Your graph will be vertical. Okay? All right, so keeping that in mind, we want to find the slope of the line that passes through these 2 points. Now, I've written our formulas down on an index card. Don't worry about this one yet. We'll need it later in this section. Okay, so I want to find the slope of the line that goes through these 2 points. So I'm going to be using this formula because this is the one we use when we have 2 points. It does not matter which of these you call x1 and which one you call y, and then, or the x1, y1, sorry, this is hard to say, x1, y1, or this one could be x2, y2, just so long as your 1's go together and your 2's go together. It does not matter. And if you think about it, if I plot 2 points, if I plot 2 points and I draw a line through it, I've plotted this one and then this one. Does it matter if I plot this one and then this one? No, I'm still going to have the same line. So it really does not matter which point you call which. And sometimes the reason I'm stressing that is you may make a choice different from the one I do, and it could be completely correct. Or maybe you're looking for help on help me solve this or something, and they do that. And I just want you to know that it's completely okay. Also, there will be times where subtracting in one direction is a lot easier than the other, and you should know that you can switch them around. But I'm just going to use them in this order. Let's call this one x1, y1, and this one x2, y2. Okay, so the slope is, formula says y2 minus y1, so 6 minus 1 over x2. Remember, I started with this 6. That means I need to start with this 2 on the bottom. 2 minus a negative 4. You want to be really careful with your signs. Okay, so what this gives me is 5 over, this is the same as 2 plus 4, 6. You're going to get just a fraction, most of the time a fraction. If it had been over 1, you would just write 5. But it's going to be a fraction written in lowest terms. You do not ever want to write a slope as a mixed number, okay? Remember that a slope is a ratio. It's supposed to give us the change in y over the change in x. And if I get an improper fraction and I change it to 1, if I had, say, 7/5 and I changed it to 1 2/5, this form, you lose the relationship. You lose the ratio. And for the same reason, we generally don't write decimals, because it is supposed to be a ratio. It is supposed to be a comparison. Okay? So the answer here is 5 over 6. Let's try this one. Same idea, we want to find the slope. So let's call these the 1's and these the 2's again. Okay, so my slope is y2 minus y1, so negative 2 minus 7 over x2 minus x1, 5 minus 5. Okay, so I get negative 9 over 0. And remember that we cannot divide by 0. If we do, we get an error. If you try it on your calculator, let's do negative 9 divided by 0. It gives you divide by 0 error. Okay, we're not allowed to have a 0 on the bottom. This is undefined. Okay, and that means I'm going to have a vertical line here, just making some connections. This one, I had a positive number, so my graph is going to be going up. 5 over 6 is a fairly small number, so it should be pretty flat. Okay, let's try this one. Negative 6, 3, and 2, 3. I want to find the slope here. Let's call these our 1's and these our 2's. So y2 minus y1, 3 minus 3, over 2 minus a negative 6. That gives me 0 over 8. 0 divided by 8. Remember, if you try it on your calculator, if you can't remember which is undefined and which one's 0, your calculator will help you out. Okay? It generally doesn't even matter what kind of calculator you have. So, okay. Even this tiny little calculator, if I try to do negative 9, I don't have a negative on this one, so let's say 9 divided by 0, I get an error message in the top here. Even this one does it. But if I do 0 divided by 9, it gives me 0 as my answer. All calculators now are programmed to give you an error message. So the slope is 0, and we know that 0 slopes are horizontal. okay? Now this, like I said, we're going to be making a lot of connections here. Over 0 is undefined, and that's a vertical line. And we notice that our x values are the same, and that's what caused the 0 on the bottom that caused me problems. Here my y values are the same, which gives me 0.